Okay, so now let's talk about quiz 2 questions. Okay, so quiz 2 has two parts. The first part is synthetic division, and we use synthetic division to factor polynomials solving inequalities. The second part is the graph of polynomials and rational functions. Okay, rational functions. So let's first look at the synthetic division questions. Okay, so suppose we have a polynomial f. So our first example, this is 3x cubed minus 5x squared plus 3x minus 1. Okay, and we have a divisor, dx. This is x minus 2. Okay, so we want to find the quotient q of x and the remainder r of x. Okay, r of x. So the important formula is f of x is the divisor d of x times the quotient q of x plus the remainder r of x. Okay, so this is the relation between f, d, q, and r. So the first remark is the divisor has to be degree 1. Okay, so in most cases we assume d of x is x minus some number c, some constant c. Okay, so we use c for constant. Okay, so this is degree 1. Okay, so if f is degree 3, then q is, so this is degree 3 if f is degree 3 in this example. So q will be degree 3 minus 1, so this is degree 2. Okay, so what is r? R is a constant, is a number. Okay, r is a number. So this is the structure. Okay, this is the structure. So now let's look at a property, right? So we know f of x is d of x times q of x plus r of x, right? R of x. So if d of x is x minus c, then we get x is x minus c. So we replace d of x by x minus c. That's the assumption, right? D of x is degree 1 times q of x plus r of x. Okay, r of x. And we know this is a number. Okay, this is a number. So what's the property? So the property is f of c. So if you replace x by c, by number c, okay, so what's going to happen for this formula? We got f of c is c minus c times q of c plus r of c. Okay, so now c minus c is 0. This is 0. So this whole thing disappeared. Then we got f of c is equal to r of c. So what's r of c? Is the remainder. Okay, so a very important property. F of c is the remainder. R of c or r of x. Okay, r of x is a number. So for any input, it's the same number. Okay, it's the same number. So that's a property. So later we will check this property. Okay, check this property. So now let's look at the synthetic division for our previous example. So let's write down f again. F is 3x cubed minus 5x squared plus 3x minus 1. And then d is degree 1, so x minus 2. So x minus 2 is x minus c. So what is c? c is 2. Okay, so this is very important. You have to know what is number c. Okay, and then we can do the synthetic division. So synthetic division, we have division inside, so it's 3, -5, it's 3, -1. Okay, these four numbers of f. And then c is 2 outside. Okay, c is 2 outside. So now first step, bring down 3. Okay, and then multiply by c, right? 3 times 2, 6. So you add them, you got number 1, right? Number 1. And then multiply again, 1 times c, 1 times 2, 2. 3 plus 2, 5. And again, 2 times 5, 10. Addition, you got number 9. Okay, number 9. So now we have two parts. Okay, we have two parts in the answer. These four numbers. This is for the q of x. And the number 9 is the r of x. Okay, r of x. So the answer for this division, f of x divided by q of x is, divided by d of x. Divisor is q of x, so this is 3x squared plus 1x plus 5 with remainder 9. Okay, so from the previous slide we know the f of c. Okay, so c here is 2. So the previous property told us f of 2 is this remainder. F of c is f of 2, so this is the remainder 9. Okay, this is the property. So you don't have to plug in 2 to check what is f of 2. You can use synthetic division to find this particular output. Okay, f of c is the remainder r. Okay, is the remainder r. So this is our synthetic division. Okay, synthetic division. So the second example in synthetic division is a little bit harder, right? So it's 5x cubed plus 4x squared minus 3, and then divided by, so d of x is x plus 1. Okay, x plus 1. So first job, we need to find c. So this is x minus c, so c is -1. Okay, so c is not positive 1, c is -1. Okay, c is always the opposite of this number in the divisor. Okay, in the divisor. So now the synthetic division. Okay, synthetic division. So c is -1, right? c is -1. So we have 4 numbers inside for division. Okay, there is a missing degree. Okay, so the missing degree is the first degree. So 0x is missing. Okay, so there are now 3 numbers inside of 4 numbers. So 5, 4, 0, -3. Okay, so for degree 3 polynomial, you have 4 terms, 4 numbers, 4 coefficients for the synthetic division. Okay, yeah. So now we move down 5. 5 times -1, -5. You add 4 and -5, -1. And then -1 times -1, 1. 0 plus 1, 1. 1 times -1, -1. And -4 is the remainder. Okay, and now we know a property. So this remainder is also f of c. So this is also f of c. So this is f of -1. Okay, so synthetic division, you can find division, dividend, remainder, quotient, remainder, and f of c. Okay, f of c. So quotient q of x is 5x squared minus x minus 1 times x plus 1. Okay, so remainder r of x is -4. Okay, -4. So that's the synthetic division. Okay, synthetic division. Now let's use synthetic division to factor a polynomial or find all zeros of polynomials. Okay, so the next question. F of x is x cubed plus x squared minus 4x minus 4. Okay, minus 4. So step 1 is the rational zeros theorem. Okay, so we want to find all zeros of f. Okay, find zeros. Okay, zeros of f. So step 1 is the rational zeros theorem. Okay, so what's the rational zeros theorem? So it's factors of the last number divided by factors of the leading number of the first number. Okay, so what's the leading number? 1 here. What's the last number? 4 or negative 4. Okay, 4 or negative 4. So we got positive negative 4. So that's the last number. So 4 has factor 2 and factor 1. So what means factors? Divisible. Okay, 4 divided by 2 divisible. So 2 is a factor. 4 is 2 times 2. Okay, this 3 is not. Okay, 3 is not a factor of 4. And then divided by factors of first number. First number is 1, so the factor is only number 1. Okay, so now all the possible C's. Okay. So they are 4 divided by 1, so plus minus 1. 4. 2 divided by 1 plus minus 2. 1 divided by 1 plus minus 1. So we have 6 possible zeros from the theorem. Okay, from the step 1. Okay, so in your exam you have to put 6 numbers. Okay, don't write plus minus sign like this. Okay, so it's 4, negative 4, 2, negative 2, 1, and negative 1. The order doesn't matter, but in your exam you have to put 6 numbers. Okay, 6 numbers online. Okay, online. So this is step 1. We get 6 possible C. So now step 2. Since I did division to find remainder 0. Okay. To get remainder is 0. Okay, so you check every C until you get remainder 0. Okay, every 0 get remainder 0. So first we got 1, 1, negative 4, negative 4. So let's put f back here, right? Function f. So f of x is x cubed plus x squared minus 4x minus 4. Okay, yeah. So our C is positive negative 1, positive negative 2, positive negative 4. So we first check C is 1. Okay, so we move down. 1 times 1, 1 plus 1, 2. And then here's 2, here's negative 2, negative 2, negative 6. So if C is 1, the remainder is 6. So we have to drop this C, okay? Because it's not remainder 0. We need remainder 0, okay? Then we check the next C. So same dividend. So this time we check C is negative 1, right? So bring down. 1 times negative 1, negative 1. And then we got 0, 0, 0 plus negative 4, and negative 4 times negative 1, so 4. And then remainder 0. Okay, remainder 0 is what we want. Then we can factor f, okay, because f of x is d of x times q of x plus r of x. If remainder is 0, then we don't have this addition part. So f of x is a product. That's called factored f of x, okay? So f of x is x minus c, so this is x minus c, right? So it's x minus negative 1. This is the c we want, right? Times q of x. So this is x squared plus 0x minus 4. Simplify a little bit, so this is x plus 1 times x squared minus 4. That's step 2. Okay, we test all possible C's. And then if you get the remainder 0, you can rewrite f as a product. Okay, f as a product. Okay, so what's step 3? Step 3, factor q of x. Okay, so f of x is x plus 1, x squared minus 4. So now you can use whatever method you know to factor the q of x here. X plus 2 times x minus 2. You can use trial and error, special formulas, quadratic formula. So this is x squared minus 4. So f of x is x plus 1 times x plus 2 times x minus 2. So we factored f. So how many solutions, how many zeros we have from f? So now we have 3 zeros, right? Make this factor 0. We got x is -1. So the first solution. Make this factor 0, x2 is -2. Make this factor 0, x3 is 2. Okay, then we find out these 3 solutions. Okay, 3 solutions for this function f. Okay, for this function f. So next question is an inequality question. Okay, we want to solve this inequality. So this is easier. Okay, this is easier. We want to solve x plus 3, x plus 6 less than 0. Okay, less than 0. So now we need zeros of all the factors, right? So this one give us the first cutting point, -3. This one give us the second cutting point, -6. Okay, so online you don't have to use subindex, okay? Just put numbers if they ask you, right? If they ask you what's the zeros of the left-hand side, just put -3, -6. So now this is our number line. So we cut here, -6, and then -3. Okay, -3. So we cut the number line to 3 parts, and then we test is positive or negative. We use number 10 if x is 10, right? If x is 10, so this is x plus 3 is 13, 13 times 16. So this is positive. Okay, so this is positive. And this is a degree 1, so we switch the sign, right? Positive, negative, positive. Okay, then we know the sign of this product. Okay, sign of this product. So now what's the interval? So let's write down the intervals. This is -infinity to -6, -6 to -3, and then -3 to positive infinity. Okay, so in the beginning, they are all open intervals. Okay, I draw 2 circles, they are all open intervals. And then you look at inequality. It's a strict inequality, so this is the answer. Okay, strict less than 0. So the answer is open, -6, -3, open. Okay, so if this is less than or equal, so you have to change these two to closed interval, right? If this is less than or equal, then the answer will be closed, -6, closed, -3. Okay, because the x1, x2, these two numbers make the product equal to 0. Okay, yeah, so we start from open intervals, and then we check 2 endpoints of the answer. Is open or closed? Okay, open or closed. So this is an easier inequality. Okay, so next one, similar. So solve this x minus 1, x plus 5 divided by x minus 2 greater than or equal to 0. Okay, so how many zeros we got from 3 linear factors? 3 zeros, right? So x minus 1 is 0. Give us x1 is 1. X plus 5 is 0. Give us x2 is -5. X minus 2 is 0. Give us x3 is 2. Okay, yeah. So when you solve inequalities, they are the same linear zeros in the numerator and denominator. Okay, so now let's cut the line, right? Cut the number line. So it's 3 numbers. So here is -5. Here is 1 and 2. Okay, 1 and 2. And then let's test. If x is 10, what happened on the right? Okay, if x is 10, so this is 10 minus 1, 9. And 10 plus 5, 15. 10 minus 2, 8. So this is positive. Okay, and then they are linear factors, so switch, and switch. Okay? So this time we want positive sign because this is greater than or equal to 0, right? Greater than or equal to 0. So now let's write down 4 intervals. Again, in the beginning, they are all closed. All open, all open. Okay, all open intervals. Okay, intervals. And then we want positive, so this is -5, 1. You use a big U, okay? So it's union, put these 2 intervals together. Okay, so on these 2 intervals, the left-hand side is positive. So now let's talk about this equal sign. Okay, so this is greater than or equal. So when this left-hand side equal to 0, so equal to 0, x1, yes. You're plugging 1 here. This is 0. So the whole fraction is 0. x2, yes. You plug in -5 here. The second factor is 0. Numerator 0, fraction is 0. But the last one, denominator 0, the fraction is not defined. Okay? So this is closed, and open. Okay, because denominator cannot be 0. Okay, so now let's put this in the answer. So 1 is closed. So change open to closed. -5 is closed, and 2 is open. So this is the answer. Okay? Yeah. So numerator closed, denominator open. Okay, numerator closed, denominator open. Okay, so one more example about inequality. So if the inequality, if the left-hand side is not factored, we have to factor this degree 3 polynomial. Okay, so first step, we write down all possible c's, right? Factor of the last one. So let's write down last over first. Okay, so to remind you, the factor of the last one divide the factor of the first one. So 6 have 2 and 3, and 1 as factors, right? 6 times 1, 2 times 3. That's the product 6. And then denominator is 1. Okay, so we have 8 possible c's, right? So it's 6, -6, 3, -3, 2, -2, 1, -1. Okay, so very important. This is the form of the answer in the exam, in the final exam. Okay, you type these numbers and separate them with comma. Okay, this is step 1. Okay, step 1. And then step 2, we check your synthetic division to check remainder 0, right? Remainder 0. So we check the first one if c is 1. So this is 1, -6, -7, and 6. So be careful about the missing degree. Okay, there is a missing degree 2 term, 0x squared. So it's 1, 0, -7, 6 inside. Okay, there were 3, 4 numbers. So bring down 1, and then this is 1, multiply, addition, multiply, addition, multiply, and then remainder 0. So we are very lucky. The first number we checked give us remainder 0. Okay, so f of x is x minus c, so x minus 1. Okay, so here is x minus c. And then times q of x, so times x squared. This is q of x, right? X squared plus x minus 6. Okay, and then you use whatever method to factor q. okay? So I will use triangle and arrow. So this is x and x. We want positive x, so this is -2 plus 3. Okay, plus 3. Okay, so first we factor f of x. Okay, f of x. So now the inequality we want to solve is x minus 1, x plus 2, x minus 3 is greater than 0. Yeah, so there's a mistake, is plus 3 minus 2. Okay, so there was a mistake in my solution PDF file. Okay, so now what's the cutting point? So this one, x1 is 1, x2 is -3, x3 is 2. Okay, is 2. So now here is -3, here is 1, and here is 2. Okay, here is 2. So now test again, use 10, right? X is 10, so this is 9 times 13 times 8, so it's positive. And then switch. Okay, switch. So now we want positive sign, so 2 positive intervals, right? Open intervals, -3 to 1, and then 2 to positive infinity. And because this is a strict inequality, so they're all open, okay? You don't have to check the endpoint, because all these numbers, these 3 numbers, make the product equal to 0. So answer is open, -3 to 1, union, open 2 to positive infinity. Okay, positive infinity. So in your exam, you can put infinity or positive infinity. Okay, so that's the part. So we can use synthetic division to solve equations or inequality. So now let's draw the graph. Okay, draw the graph. Part 2, okay? Draw the graph of this polynomial. Okay, so in the beginning, it's very similar. We list out possible c's, factor f, and then find plus minus sign. Okay, it's almost the same. Okay, almost the same. So c is the last over first. So this is 3 and 1 over 1, right? Denominator 1. So c is -3, +3, -1, +1. Okay, so we have these 4 possible c's. Okay, possible c's. And then we check them until we get remainder 0, right? So c is 1. So -1 is 3, 1, -3. So bring down this, product 1, negative. And then this is 2, product 2, 1 plus 2 is 3, and then 3, remainder 0. Okay, so we want remainder 0. Okay, remainder 0. Then we got f is x minus c, so x minus 1 times q of x. Q of x is negative x squared plus 2x plus 3. Okay, and then we can factor this. Okay, you can use quadratic formula, whatever you have. Okay, yeah. So we got x minus 1, and then negative x plus 3, and then x plus 1. Okay, so in the beginning we factor f. Okay, factor f, and then we got 3 solutions, cut intervals to find positive negative sign, right? So let me write down the product again. Okay, so now let's look at 3 solutions. This is 0, so x is 1. This is 0, x is 3. Okay, there's a negative sign here. Okay, negative sign here. And then the last one is 0, so x1, x2, x3. So this is -1. Okay, -1. So they are all the x-intercepts. Okay, so x-intercepts. We're talking about graph now. Okay, x-intercepts So in the exam, it looks like this. X is equal to a box, answer box. Then you put 3, 1, -1. The order doesn't matter. Okay, the order doesn't matter. Okay, so now let's draw the line, cut the line, and then put positive negative sign. So here is -1, 1, and 3. Okay, first we test 10, right? If x is 10, so this is 9 times x minus 1, and then this is -7, and then times 11. So it's negative, okay, negative. So the beginning sign is negative, and then we switch to positive, switch to negative, switch to positive. Okay, yeah, we're not solving inequalities, we're drawing graphs. Okay, we're drawing graphs. So now we have to, this is the x-axis. Okay, you see we have 3 intercepts. That means the graph, the graph of the polynomial has to pass these 3 circles. Okay, so positive sign means the graph is on the upper half plane. Negative sign means the graph is on the lower half plane. Okay, so what's the graph? Graph is x comma f of x. So if f of x is positive, that means upper half plane. F of x negative, that means lower half plane. So where is the y-axis? Y-axis is in the middle here, right? Between -1 and 1. Okay, so here is 0. Right here is 0. So now let's draw the graph. Okay, let's draw the graph. So here f is positive, so in the upper plane, upper half, and then go to 0. Okay, so on this number -1, f is 0. And then you decide it's go down or go up. So here's negative sign, so it's go down and then go back to 0 at x-intercepts. And then it's positive, so go up and then go back to x-intercept and then go down because it's negative. Okay, so this blue curve is the graph of f. Okay, blue curve is the graph of f. So now the last question we need to know is the y-intercept. Okay, so what's the y-intercept? That's a property. Y-intercept is the last number. Okay, is the last number of f. Okay, so let's rewrite f. F is -x cubed plus 3x squared plus x minus 3. So what is this y-intercept? This y-intercept is the last number here. So this is -3. Okay, so y-intercept, y is equal to an answer box. So you should only type -3 when you answer the question online. Okay, y-intercept is -3, is the last number of f because you plug in 0, right? When you plug in 0, so if this is 0, so then all these disappeared, right? All these terms disappeared. The y-intercept is the last number. Okay, so is -3. Graph of polynomial. Okay, polynomial. So the last question is the graph of a rational expression. Okay, rational expression. So you have numerator and the denominator. Okay, denominator. So we have numerator. So let's write down numerator. 2 minus x. And the denominator. Okay, so zeros of numerators, they are x-intercepts. Okay, so numerator give you x-intercepts. So that means the graph will pass zeros of numerator. Okay, so this is 0, implies x is 2. So this is x-intercept. Okay, so x-intercept, x is equal to, there's an answer box, and then you put number 2. Okay, 1 x-intercept for this example. So what's zeros of denominators? Zeros of denominators are vertical asymptotes. Okay, so this gives us vertical asymptotes. Okay, so this is 0, x minus 1 is 0, implies x is 1, so x2. And x plus 1 is 0, implies x3 is -1. Okay, so these two zeros from the denominator, they are vertical asymptotes. They are not x-intercepts. Okay, so vertical asymptotes, x is the answer box. So we have two numbers, 1 and -1. Okay, 1 and -1. Okay, yeah. So now let's look at positive and negative sign, right? So let's draw it here. So we have x1, x2, x3. So x1 is 2, and then 1, and then -1. Okay, so we do the same thing, plus and minus sign, right? So we test x is 10. So x is 10. Numerator is -8, 2 minus 10. And then we have 9 times 11. So this is negative, positive, negative, and positive. Okay, so that's the sign. Okay, that's the sign. Okay, yeah. So now where is the y-axis? So let's use the purple color, right? Y-axis is between -1 and 1. This is the y-axis. Okay, so x1 is y-intercept. So that means the graph will pass this number 2. Okay, pass this number 2. And 1, -1 are vertical asymptotes. So they are the vertical walls. Okay, so these are cutting walls. They cut the plane to 3 parts. Okay, to cut the plane to 3 parts. Okay, so the graph cannot pass -1 and 1. Okay, they are vertical asymptotes, cutting lines. Okay, cutting lines. So now let's make this graph better. Okay, better. This is 2. There is a cutting wall. -1, there's another cutting wall, 1, and then y-axis in the middle, right? Okay, yeah. So now we know x-intercept, vertical asymptote. So what's y-intercept? Okay, what's y-intercept? So y-intercept, we plug in 0, right? We need to know f of 0. So f of 0 is 2 minus 0 over 0 minus 1, 0 plus 1. So it's 2 over -1, so it's -2. Okay, so this is the y-intercept, -2. Okay, -2. Okay, so now what's the horizontal asymptotes? Okay, horizontal asymptotes is the maximum degree. Okay, use the maximum degree of numerator and denominator. Okay, so f of x is 2 minus x, and then x minus 1, x plus 1. Okay, so if you simplify the denominator, this is x squared minus 1. So here we have degree 2. So we use degree 2. Okay, numerator degree 1, denominator degree 2. So we look at degree 2 terms. Degree 2 on top, 0. Degree 2 on bottom, 1. So horizontal asymptote is x is equal to 0. 0 over y is equal to 0. It's a horizontal line. Okay? Yeah. So we look at the maximum degree on top and bottom, and then we got the horizontal asymptotes. Okay? So horizontal asymptotes is this x-axis. Okay, x-axis. So that means the curve will approach to that line. Okay, so now let's put plus sign, minus sign back on the picture. Okay, so now we need to draw the whole graph. Plus sign. No, the first one is minus sign. Minus sign here, and then plus sign, and then minus sign, and then plus sign. Okay, 2 is a dot. So that means the graph will pass 2. Okay, these are 2 circles. They are vertical walls. Okay, vertical walls. Okay, so now let's draw the graph. So now we know the curve is positive after 2. Okay, so it's go up, in the upper half plane, but you can approach the wall but never go the other side of the wall. So this is positive side. And the negative side, so we know you have to go to negative side, so it's the lower half plane, but we know the horizontal asymptotes. Okay, this is horizontal asymptote. HA. Horizontal asymptote tells us, okay, so when you go very long, very far, it will go back to almost x-axis. Okay, so now this is from the y-intercept, so this is on the curve, on the graph. And always negative, so go down forever, go down forever. It cannot go up, okay? But it also cannot go to the other side of the wall. And this is positive, so you can start from anywhere and then go up, approach the wall, but never go the other side of the wall. And this go when you go very long, so that's meaning of horizontal asymptotes, okay? When you go very far, you approach to the horizontal asymptotes. Okay, so that's the graph of the rational function. Okay, rational function. So that's the last one. Okay, last question in the quiz 2 review list.